Lies. Lies. We are told that nuclear energy emits no greenhouse gas emissions, but lies. Honestly, these people haven't been sincere towards us. They hide things from us in order to distort facts and push their agenda. This is why we have this platform to evaluate the pros and cons of various issues, address benefits and challenges, and to remain neutral in our analysis, because our aim is not to push any agenda, but to keep you informed. According to the Nuclear Energy Institute, nuclear power plants do not emit carbon dioxide or pollutants into the air. According to the International Atomic Energy Agency, nuclear power plants do not produce greenhouse gases or other air pollutants while operating. According to the World Nuclear Association, nuclear power plants do not burn any fuel. Instead, they use uranium fuel consisting of solid ceramic pellets to produce electricity through a process called fission. However, ladies and gentlemen, what they don't tell you is that a nuclear reactor requires an external source of energy to function. Nuclear reactors require a specialized fuel called nuclear fuel, such as enriched uranium, and the enrichment of uranium is powered by what? Fossil fuels. In this video, we are going to examine the emissions generated from nuclear fuels, and then we are going to examine conventional fuels like coal and natural gas used to power nuclear reactors. We would also address the environmental and safety impacts of nuclear energy, which are deliberately kept from the public and in an attempt to mislead us rather than educate us. So, first, nuclear fuel. Uranium is a nuclear fuel used in nuclear reactors and can be found in many places around the world. However, the uranium used in reactors is different from the natural uranium. This is because for it to be used as nuclear fuel, it has to undergo refining and enrichment powered by fossil fuels. In details, natural uranium consists of three isotopes: uranium-238, uranium-235, and uranium-234. Majority of nuclear power reactors use the isotope uranium-235 as fuel. However, it only makes up 0.7% of the natural uranium mined and must therefore be increased through a process called enrichment. This means that the most suitable uranium that is required for nuclear reactors is very scarce. So, what do? They enrich the scarce ones, the common ones rather. They enrich the common ones such as uranium-238 and 234 in order to meet up with the quality of uranium-235. So this enrichment process increases the uranium-235 concentration from 0.7% to between 3% and 5%, which is the level used in most reactors. The two most common methods of uranium enrichment are gas diffusion and gas centrifugation. They both require significant amounts of energy to operate. Gas diffusion involves passing uranium hexafluoride gas through a series of barriers, while gas centrifugation involves spinning containers of uranium hexafluoride gas at high speeds to separate the uranium isotopes. Note that both methods require large amounts of electricity and power to operate, which is typically generated from conventional fossil fuels. So let's look at the aspects of conventional fossil fuels where they operate in the nuclear power chain. So the fact that nuclear reactors run with uranium does not mean conventional fuels are not applied in the nuclear energy production process at all. Conventional plants such as coal-fired or natural gas-fired power plants may be used to generate the electricity needed to run various parts of nuclear fuel cycle, from uranium mining and milling to fuel fabrication to reactor operation and waste management. However, these fossil fuel power plants do not usually direct power the nuclear reactor itself, but they are still involved in the chain of production of nuclear energy. Next is the environmental impact. Nuclear power plants require large amounts of water for cooling purposes, which can be a challenge in areas with limited water resources. Additionally, nuclear power plants produce radioactive waste that can remain dangerous for thousands of years, and the safe storage and disposal of this waste is a significant environmental concern. Furthermore, nuclear accidents such as the Chernobyl and the Fukushima nuclear disasters have demonstrated the potential for catastrophic environmental damage in the event of a nuclear accident. Despite these drawbacks, however, the use of nuclear energy can provide a low carbon source of electricity, which can help to reduce greenhouse gas emissions and address climate change. In this video, we have been able to establish that 1. Nuclear energy is not produced without carbon emissions. 2. And it is not without environmental and safety concerns. However, the use of nuclear energy can provide a low carbon source of electricity, which can help to reduce greenhouse gas emissions and address climate change. That fact is indisputable. It must be noted that no energy source is 100% clean, but the benefits of nuclear energy and its efficiency outweigh its side effects, so it makes it comparatively better than its other clean energy counterparts like solar and wind. Thank you for watching. This is the Energy Brief with Twitter, where you get reliable and trusted source of information and updates on the energy industry, and you also get educational content which you would love to see over and over again. So make sure you like and subscribe to continue seeing us. Thank you very much.